Hi everyone, welcome back to another multimeter review. My name's Darren, and hope we learned something today. Today we're looking at the SANWA CD771. This multimeter is not a true RMS multimeter. It hails out of Japan, but funny enough, and I was a little peeved initially, but when I'm ordering multimeters, what have you, I have a certain, let's call it a penchant for Japanese multimeters, German multimeters, American multimeters, and one of the things I try to do, at least criteria-wise, is to have a mixture of different testing equipment. We've often heard really good things about Japanese quality, Japanese precision, what have you. So that was one of the reasons why I initially chose this SANWA CD771. When I received the package, and I've had this meter now for approximately 9 months, the first thing that I noticed was this. Yeah, made in China. So I was upset and a little frustrated at first. If you notice when you're purchasing multimeters, I live in Canada, and to purchase a SANWA multimeter is very hard. There's very, very few distributors in this country, and Canada is a pretty large country. So chances are, if you want something different like SANWA, Hioki is a little easier to source. But as far as SANWAs are concerned, you don't have many options. So I purchased the meter off of eBay through a very good seller, I must say. Anything Japanese meter-wise, I get from the same seller, and I will put a link to some of his stuff down below. So when I received the multimeter, I was a little upset. Made in China, you know, when it's being posted online, a lot of times you'll see from Japan. From Japan. This can be deceiving, you know. You can call it what you will. But personally, if you're going to promote a product, I think you should be upfront and say this item is made in Japan. It's made in Japan. Don't say it's from Japan. Don't say it's from the United States, made in China, what have you. You know, people want to know, especially when it comes to electronics, devices per se. These aren't, you know, super cheap devices, and it's always nice to get all the facts up front before you pull out your hard-earned dollars. Anyway, obviously I kept the meter, and we're going to be reviewing it today. In comparison to its other brother, the CD732, this one has a few interesting features, which we're going to go through. But before we do that, we'll start off with, what do you get? Well, initially you get the typical SANWA box. It's a nice box, mind you. It's very sturdy, solid, compared to some the interesting packaging boxes you get with certain multimeters. The SANWAs are nice. It's sturdy. There's bubble wrap when it ships. No complaints in that department. You get your SANWA CD771 manual. It's in Japanese and English, and actually they're pretty good. I have no complaints. It goes through all of the basic testing methodology, criteria, accuracy. So for spec-wise, it's a pretty decent little manual. You also get this Sanwa Certificate. It's a approved certificate of inspection. We certify that this product's passed the quality control inspection. Now, obviously, if you're in need of certain calibration prerequisites, I don't think this will fly, at least not in North America. but at least it tells you that it's had the once over, so technically it should hopefully be fairly accurate. Now also you get these fantastic, and I really mean I love these leads. I always talk about it in my videos, but for me they're probably the best leads. I like them better than my wonderful probe masters, than the Agilent leads. I've got a lot of good probes, and I'm always coming back to Sanwas. I don't know why, just for me, in terms of the way they feel, the nice gold tip on them, fairly sharp. For me, they just feel perfect. So if something works for you, despite what other people say, just use it. I love probe masters. I love some other leads too, but you know, I'm really liking these. These, by the way, are called the TL23As, and they're a yeah, like I said, they're just a really great. They're rated for 20 amps, and I believe it because they really feel quality. The meter itself, it's a 4,000 count, 3 times per second sampling meter. It's rated at Cat 2 1000 volts, or Cat 3 600 volts. It has a battery warning indicator that initializes when you get below 2.4 volts. When that happens, change your battery. I've seen a lot of people and a lot of videos where people are doing tests and you see the battery warning indicator. It's either steady or it's flashing. You're not going to get accurate readings. So when your battery fails or is getting low, rather, replace it. Put in a fresh battery and away you go. I would not trust any reading that was done when I see a battery indicator light on. In terms of specs, you've got it's an auto-ranging multimeter. You have a rel button, range hold button, data hold, and your selector. Now the selector is for instance, in the selector switch here, got a variety of different measurements. You got the ohms, diode, continuity, so to cycle through those, you just hit your select button. In terms of resistance, this multimeter, the CD771, does up to 40 mega ohm, which should suffice for most people. Honestly, myself, I've never had to measure anything higher than probably 15-20 mega ohm was tops. Normally it's 10 or under. And I'm a hobbyist. I also do electronics for a living, slightly different angle, but I've never required anything over 10 or 20 mega ohm tops. So 40 mega ohm is great, no complaints there. I do have a complaint though in terms of its capacitance. It is only rated for 100 microfarad. Now I don't know about you, but for myself, 100 microfarad, yeah, that's good, but this day and age, it's just sucks. I'm sorry. Did you hear me, Sanwa? You got to do better than 100 microfarad. For a meter at this caliber, this quality, it really needs to, at least in my eyes, be capable of at least 1,000. But anyway, it is what it is. It does from 50 nanofarads up to 100 microfarad, and we will test that out shortly. In terms of the frequency, it does up to 100 kilohertz, so that's always great. And one interesting function that you'll notice is that it has something here, and it's a battery testing mode. And what that does is you have to swap the leads, put into the battery mode. Now this only works for 1.5 volts, and it puts a 30 ohm measure of resistance on that battery. So if you have a weak or dying battery, it'll definitely fail the battery test. So that's kind of a unique feature. Is it really necessary on a meter in this range? I don't know. Probably not. But that being said, it's there, and it's kind of neat. You can see the display itself, typical with most Japanese multimeters. It's really nice, very crisp, clean digits. I'm not sure what it is exactly. I mean, for me, liquid crystal is liquid crystal, but somehow the Japanese always seem to do it a little bit better. It just seems much more aesthetically pleasing. So, yeah, I've got no complaints about the display. Now, my biggest complaint in terms of the mechanics of this meter is the backlight. And I'll demonstrate it. I'll just turn the lights down here. Now, the backlight is also the data hold switch. So press down on the backlight, hold it for 2 seconds, and there you go. So you've got these two very faint, I'll call them ambered LEDs on the right hand side of the display, and honestly just really bad. So yeah, thumbs down for the backlight. Now, I guess the only positive thing about the backlight on this is the fact that it has one, because like its other brother, the CD732, this one has no backlight. So I guess any backlight is better than none, but yeah, it could have been much better. I currently have the Sanwa CD771 hooked up to the 8584-M voltage reference. We are currently on the 2.500 range, and we're about 10 counts off. We're showing as 2.490. Bring it up to the 5.00 range, and the Sanwa's reading 4.98, so 2 counts off, not too bad. This is the 7.500 range, and the Sanwa is reading 7.47. And finally, the 10 volt range, 10.000, and the Sanwa is 4 counts off at 9.996. So, in terms of accuracy, it's okay. It's nothing spectacular or stellar. This meter range, price-wise, it is in approximately about $100 Canadian, so about $80 US, $75 to $80 US. So yeah, I mean, nothing to write home about in terms of accuracy, but it's not bad. It's okay. It's definitely doable, and I've got no complaints in that department. Actually, I thought it would be fun to pull out the also popular AN8008 Anning and just run through the same series of voltage tests quickly. So currently on the 10.000 volt setting, and the 8008 showing 9.996, 9.7, and it mimics the Sanwa 9.97. All right, let's go to the 2.500 range. Sanwa showing 2.491, and the Anning is closer at 2.4978. So better than the Sanwa. 5.0 range, 4.99 for the Anning, which is a higher resolution. As you can tell, the Anning is 10,000 count, and 4.98 for the Sanwa. Finally, the 7.5, 7.49 for the Anning, and 7.47 for the Sanwa. So there you have it, folks. The El Cheapo $15, $20 Anning beats out the from Japan, made in China, CD771 Sanwa. Alrighty. Now, since I got the Anning out, I decided to do the frequency test. The Anning has a little frequency generator, so I put the Sanwa to the frequency range, and we'll see how it fares. So right now, let's see what we've got here. Oh, I think we have a little bit of static. Let me just take off the other probes. Okay, so right now we're on the 50 hertz range, the Ning, and pretty well right on 49.99. The Sanwa, let's take it up to 100, 99.9, 199.9, 300, 300.4 on the Sanwa, 400 hertz, 500 hertz, 600, 700, 800, 900, 1 kilohertz, almost spot on with the Sanwa, 2 kilohertz, spot on, 3, a little less, 4, up to 5, and now we're maxed out with the Ning for the frequency generator. But there we are, spot on. So yeah, no complaints there. The frequency range for the Sanwa is good up to 100 kilohertz. So great, awesome. Okay. So now what we'll do is we'll do a couple of basic measurements. We'll start with, I guess, resistance. I've got a actually, I think we'll do one resistor in this case. This is a nice and big, you can read that. It's a 10 mega ohm resistor. So put it on the ohms range, and let's see how the Sanwa does. So nice and fast, and there you have it, spot on, 10 mega ohm. So no complaints in that department. Go over to capacitance. I have a few capacitors. One is a little Japanese, 0.1 microfarad. Now one thing, if you can see here on the, I do apologize for the glare. On the Sanwa we've got some noise here in the capacitance range. It's showing 0.53 nanofarad. So I'm going to rel that out. Alrighty, so now we're at 0. I don't know why that's happening, but I've noticed that since the get-go. I always have to rel out. And most multimeters, you know, really shouldn't have to. For instance, if we just cycle through here for the Ning, I mean, by default, you know, there's no noise at all. It's where it should be. It's a little disappointing why there's noise on this Sanwa. Anyway, reled it out. So we'll take this 0.1 microfarad cap, and there we go, pretty well. 107.3 nanofarads, very close. Now this is a non-polarized capacitor. It is a whopping 22 microfarad, so it doesn't matter which way we put the leads. Let's see how close we get to 22. 21.85. That'll work. Works for me. Awesome. Now, unfortunately, as I had mentioned previously, this meter is only capable of going up to 100 microfarad. So I have discovered a 100 microfarad on the bench. Let's see. Now this one is polarized. Electrolytic capacitor. Here we go. How close do we get to 100 microfarad? It's thinking. Wow, that is slow. Over limit. Go figure. See? And this is a 100. Just double check. Yes, it's a 100 microfarad. Capacitor. I know it's really hard to see. So yeah. So that's shameful, Sanwa. Come on. If you're rating it for 100, at least do 100. Let's try it one more time. I'm going to do it over here. I'll actually turn it off, turn it back on. Do we have to rail it out? Yes, we do. So we're railed out and try it again. 100 microfarad. What do we got? Try not to touch anything with my fingers. Okay, so it's thinking. Thinking. And over limit. Boo! Very disappointed, actually. No, I don't have anything close to this range, but you know, at the very least, yeah, very disappointing. So rate it at 100 microfarad, and it cannot read 100 microfarad. Now, just to be fair, I will pull out. Where did I put the NA? Ah, there it is. Since we're using this guy, I mean, I'm surrounded by multimeters, but let's just try this quickly. At least we can verify this is truly 100 microfarad capacitor. Alrighty. The little standing bail. Okay, so hope you can see this properly. I've got the Sanwa leads on the Anning as well, so nothing's changed. Same capacitor, same leads. Here we go. Whoops. Okay, so it looks like I had the Anning set to the wrong setting, so it helps if you put it on capacitance, which it now is. And yeah, the Anning is capable of measuring. It's rated at over 10 megafarad, so 100 microfarad is nothing. Just to double check, we'll hook up the same capacitor that the Sanwa was incapable of reading, and let's see what we've got. And there you go. Whoops. And there it goes. Right on. So 109, 110 microfarad. 100 microfarad. Boo Sanwa. Alrighty. So that was disappointing. I was expecting at least slightly over the 100 microfarad range, but it's not to be. Okay. Now this has this interesting 1.5 volt battery feature. So if I can find a 1.5 volt battery, we'll test it quickly. Put it on the battery setting. I've got a Toshiba carbon zinc battery. Now, here you've got this very interesting rubber protector, so because I'm testing the battery now, the red lead has to go directly in there. These are just rubber. Has a nice feeling. By the way, the weight of this meter is actually quite heavy. It's a very solid, very good feeling meter. The holster does not come off. It's part of the entire chassis, but it has a very nice feeling to it. It's kind of got that old, for me, 1970s blue-gray kind of industrial look to it. You might or might not like it, but it's okay. I like it. It's a decent looking meter. Okay, so let's see what we do. Now, once again, this is going to put a small bit of resistance on this battery. Now, let's see what we have. Get rid of the capacitor. Okay, so it's showing as 1.53 volts. And that's with a small load being put on the battery. That's what the setting is for. So it's very good battery. Now if we try the same setting, just in typical voltage mode, let's try that, shall we? So we had a 1.53 reading. Let's see what we have now. 1.63. So you can see now it's showing as more of a charge. That's because the load is not on the battery anymore. So yeah, it's a neat little setting. You have to do a lot of battery tests for 1.5s. Well, there you go. Great. We're now in diode mode. I've got a small set of diodes here, and we'll just try testing one. And 0.478 for voltage drop. If I reverse the lead, should have nothing and nothing. So that works great. I've got a couple of LEDs here, light emitting diodes, so we'll try those for the heck of it. See if they can be lit up. Try the first one, the red one. It's lower voltage. Let's see what happens. And nada. We'll reverse the leads. And nada. So it can't even light up a very low voltage red LED. So I won't even try with the white. So that's disappointing. Okay, well, what we'll do next is we'll take the meter apart, have a little look at the insides, and we'll see what's cooking. Now with the Sanwa, as I said, the holster is all one assembly. Neat thing about it is for the battery pack, you've got one screw, and it's a metal insert. Top comes right off. So you've got a nice insert there. Very well done, Sanwa. And there's the two 1.5 volt batteries. But we have to go further because we want to see inside this puppy. One interesting feature, let me just show you that quickly. On the battery pack itself, it says, if you can read that, it says Tokyo, Japan. Okay, it doesn't say made in Tokyo, Japan or made in Japan. It just says Tokyo, Japan. So don't be fooled. If you're really concerned, if you really want your meter to be from a certain country and you're not sure and you need clarification, ask the seller. Say, listen, is this meter actually made in Japan? Once again, this is made in China. So we've got two more screws, Phillips, on the bottom. Take those off. Take a look inside. My God, I'm so excited. It's very therapeutic, you know. And in like Flynn, no. Or as they say in Russia, нет, товарищ. Нет, хорошо. Okay. Alrighty, so lift it up. And are you ready? 1, 2, 3. Ooh. Alright, so we'll start with the boring part. No shielding. Why? Why? For the love of God, I don't understand why. ABS, nice rich, nice blast protection here all along the base. It's not waterproof or anything, no IP rating, so there's no gasket per se, but a little piezo, a little cheap looking piezo actually. Yeah, so no shielding at all. Boo, boo, boo. Why? I'll never understand this. Okay, now we'll take a look at the inside. See what we've got here. Okay, so just taking a closer look, we have a couple of nice HRC fuses here. 10 amp for the current range. Nice current shunt, nice and long and thick. A lot of resistance there. Smaller 500 milliamp fuse, also ceramic. These are both SEBA fuses. The leads, if you can tell, so it's your sort of standard little prongs that have been soldered onto the PCB. I'm not a big fan of that. And we got some flux here, actually a lot of flux residue down here. Okay. Alright. They're the split type. Now they're on these plastic capsules, so I really don't think they're going to come loose. If they do come loose, it's going to be because the soldering joint would eventually wear out, but yeah, well, it is what it is, I guess. I'm not super crazy about it. The rest of the PCB looks fairly decent. This is the connectors for the piezo, the little springs here. We got 2 PTCs, which is always nice to see. And we have a little GAP device right here. You don't see that all the time. Going down the board, a lot of resistors, more caps, some trim pots over here, some surface mount caps on top, crystal oscillator here, some more surface mount caps. And we've got the leads for the battery been soldered directly into the main board. So all in all, it's you know, it's not bad. It's okay. It's good. It's you know, you definitely have the input protection. There's no question about that. Some of the techniques, maybe the soldering could be a little bit cleaner. I'm going to go ahead and take the rest of the screws out, and we'll have a look on the other side. Okay, so I've taken the PCB right off, and this is the chassis side. As you can see, we've got some really nice gold contacts, and different size ones, and some nice lubing going on the selector switch. That's always good to see. These are the rubber push selectors for the inputs. Here is something kind of unusual. It's a very small elastomer strip. This is what feeds the LCD display. But in this case, it's really small. Usually they're twice as long as that, but very interesting. So a very tiny elastomer. Okay. Now I'm just going to put that down, and we'll bring up the PCB. Oh, by the way, this is the plastic or the rubber housing that for the tips here on the back. Okay, so now we're on the other side, and as you can see, we have a few interesting little items here. The main IC is an FS911, sorry, FS9711-LP3. That's a Fortune Semiconductors, I believe, IC. It's not a Sanwa developed IC. Unlike Hioki, Sanwa does source out some of its integrated circuits. In this case, here's one of them. Get you a closer look here. Quite popular, readily available, and fairly inexpensive to mass produce. You can see here, this looks like the 2016, the manufacturing date. I don't see any rev, so this might be a first gen PCB. Decent gold plating on the selector rotary switch. Here's the LED. This is for the continuity testing, which I did not do, which we'll do quickly before I do a recap. So that's the LED for that. These are the solder joints for the battery connectors. This is the very small array for the zebra strip, the elastomer that we looked at that was really tiny. So that's what talks to the digital display and gives us the readout. If you can, do not try to touch this with your fingers. It can create all sorts of bad stuff, and what you got to do if that happens is take some alcohol, put it on a cotton swab, give it a good cleaning. It's actually a good thing to do if you have older multimeters. It's really good preventative maintenance and keeps the display crisp and clean. Going down the display, we see the Sanwa logo, some surface mount resistors, and I see, it's hard to see, let me just get a closer look here. I want to make you seasick with all this movement. Okay, looks like it's a bridge rectifier, a DF04S. So that's a bridge rectifier right at the bottom here, and I believe that is from Vishay Semiconductors. Interesting. Once again, this is the connectors just soldered on. So there you have it, the inner workings, and of course the knob selectors for the push button selecting switch. Another good preventative maintenance tip is to, if you're going to clean the display, do the same thing here with some isopropyl alcohol. And sometimes people have lack of response with their push buttons after a couple of years. So just cleaning these selectors right on the PCB with alcohol can help you from having that problem. Alrighty, so I'm going to put this guy back together and we'll do a quick continuity test, and I'm probably going to clean up some of the flux residue on this board because there's a little more than I like, and then we'll do a recap. Okay, I thought I would do this on camera. This is something called a flux remover pen. This one's from MG Chemicals. They're great little devices. Actually, this guy's probably due to be replaced. But I'm just going to take him and I'm just going to gently go over the areas here where I see some flux residue. Because that's not a good thing. You don't want to have all this on your PCB. It can introduce all sorts of little problems. So just give it a good once over. Okay. And then you can go to your local electronics store and you can spend $10, $12 on cotton swabs with little wooden tips. Or you could go to the drugstore and spend $1, which is what I normally do. Get your good old Q-tips. I'm going to dip it in the 99% isopropyl alcohol. So it's on my tip, and I'm just going to gently go over the PCB. So where that flux was, now also these connectors here. Yeah, this board had a lot of grime on it, so it's not good. You don't want to have oxidation. You don't want to have, you know, any sort of particles. You want to try and keep this as clean as possible, because after all, these are electronic instruments, and you don't want to introduce any sort of third party irritants on them. Okay, so I'm pretty happy with that. Alrighty, so I'm going to put everything back together and we'll do a quick continuity test. Okay, I promised you a quick continuity test, so here we go. So it's unlatched, surprising. It is fairly quick though. And the thing I do like is that you've got the nice continuity. Sorry, I ran out of memory there, but yeah, you've got the nice continuity, the visual indicator as well, which is always a bonus, especially if you're in a noisy production environment. Okay, so let's sum things up quickly. The CD771 Sanwa digital multimeter. From Japan, but not made in Japan, unfortunately, made in China. For me, that makes it lose some of the inherent, quality that you come to expect with a Japanese-made precision instrument. I'm not impressed with the specs. 100 microfarad, it failed even at that. It's decent built. It's got good input protection, nice big HRC fuses, PTCs, what have you. No shielding at all, again. But just generally, I don't feel like I'm getting bang for the buck with this meter. We're talking $100 plus Canadian. What can I say? It's not true RMS, but even at the basics, I think it's lagging behind today's multimeters. And it's a relatively new multimeter. My PCB was dated as 2016. So yeah, I was expecting more. So out of 5 stars, I'm going to give the CD771 2 stars out of 5. Thanks for watching. Till the next video, keep on testing.